this is going to be just a short session regarding color theory. So color theory is going to be how color works, how you manage color, what makes color in the first place, and understanding how colors fit in with black and white. Black is the absence of all color. White is the presence of all colors. So colors involve three basic colors, and this is a color wheel, which you've probably all done on, in school, lower grades. You've got your primary yellow, primary red, and primary blue. Of these three colors, all other colors are made. When you mix these two, you get orange. Red and blue make purple or violet. Yellow and blue make green. In between these, you have varying hues of each color. You have a brighter orange, a deeper orange, a more red purple, more blue purple, and so forth. So when we say white is the presence of all color, what that means is that white light, which would be basic sunlight, would be white light. This would be your white light. This is a ray of white light. White light is made up of your three basic primary colors and your three basic secondary colors in equal parts. When they all come together, they make white, and that is a ray of light, sunlight. When a ray of white light hits something that either breaks it apart or absorbs some of these individual rays or colors, but this is actually a ray of light. When some of these beams are broken and separated from the others, we have individual colors. So what we're going to imagine happening is a ray of light is coming in, it hits a prism. And you guys have all done this in science class too. As it goes through the prism, these colors are separated and they come out the other side, individual red, individual orange, yellow, green, blue, and purple. So now this ray of light has been separated and now you have colors. With black, there is no pigment. There's no way to separate it. There's no way to put life into it. Color brings life to a painting or a room or a house, whatever. But black, which is often used in artwork, is a very dead color. So it's actually not even a color. One other way that light can be separated or broken apart is through chemical compounds called pigments. So let's say we have our red coming in. We have our yellow down here. We have our blue down here. We have purple. We have, I'm gonna get my orange. We have orange, and we have, oh, hang on, I gotta find my green. And we have green. All coming at this apple, which looks red to us when we look at it. Well, it's not red because it's fracturing light, and red is coming at us. It's looking red because as these all come in, the pigments in this apple absorb everything, and they all go right on through. They don't turn into anything. It absorbs them. It reflects the red back to our eyeballs. So we see the red because of pigment. So that's how paints get their color, is through pigments. Now the prism will fracture light rays also, but there are other things in nature that have a structure that will break apart light because they're smaller than a ray of light, or than a ray of, they're not smaller than these rays of color, they are smaller than the white light. So when the white light comes in, it's a combination of all these colors. It hits these little shelves, you might call them, and it ricochets them back out. And that happens every time it hits another little section of this this sort of a structure you'll find in fish scales, bird feathers, flower petals, all sorts of places. But that's kind of how they make light turn into colors. So when a white light comes in here, it reflects back out, and as the angle changes, it becomes whatever color. Red down here, if it's the blue is ricocheting back out, and it combines with this red, you're going to have purple. This is what, this sort of a thing is actually what produces iridescence. So when we have the prism, we are seeing color, white light fractured. We're seeing the colors, but this is doing the same thing, but it moves. So it moves with the bird, it moves with the fish, it moves with whatever the structure is attached to. And because of that, you make it purple here. And then when it moves, this bends and moves, these colors come in at another angle. Might turn into orange, might turn into green, but that's called iridescence. So one more picture here. This is how light works with the atmosphere. So if this is the Earth, we have the sun up here. When the sun is directly above us, the skies always look blue, like they are today. Blue is the shortest ray, the shortest color coming in with white light. As we look straight up, we can see those blue rays out of the color scheme that's coming in the white light. As the sun goes down and moves this way, let's say that's the way it's going, now the rays are coming in at an angle, and as this whole thing turns, these longer rays, which are the reds and oranges, and in between you're going to have the yellows and the purples and the greens. Everything is twisting this direction. These longer rays, the reds and the yellows, are what you're going to see in the sunset. And they are coming through this area that's atmosphere. So now you've got something in the air that is actually breaking apart the rays of light. So those that are short, we just don't even see them. Those that are longer get in here. That's why you have red separated from yellow, separated from orange, and sometimes green in the sunsets. So that's basically color theory. We're going to just stop it right here. In the next segment, we'll go into color names, how to mix them, and how to put them on a canvas.